Lesson 8-4, Graphing Rational Functions, Part 1. Objective, graph the rational functions with vertical and horizontal asymptotes. Let's take a look at where we would look for a vertical asymptote. We will look for a vertical asymptote when the denominator is equal to 0. Let's take a look at this function right here. The denominator will be equal to 0 when x is equal to -1. And notice we do have a vertical asymptote at -1. Over here, when we look at the denominator, notice that there are two values that can make the denominator equal to 0, and that's x equal to -1 and x equal to 1. And notice that we do have these vertical asymptotes. Over here, the denominator is going to be 0 at x equal to 3, and these are our vertical asymptotes. Now let's discuss where we could find horizontal asymptotes, and it has a lot to do with the degree of the numerator and the degree of the denominator. When the degree of the numerator is greater than the degree of the denominator, there aren't any horizontal asymptotes. Let's take a look at this case. The degree of the numerator is 2 because we have x squared. The degree of the denominator is 1 because it's x to the first power. In this case, we have no horizontal asymptotes, and notice in the graph there aren't any. Over here, let's take a look at the numerator. The numerator's degree is 0, and the numerator's degree here is 2, and this is our second option. When the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is the x-axis, and we can see that right here. So the horizontal asymptote is y is equal to 0. In our last case, we can see that the degree of the numerator is 1, x to the first power, and over here it is 1 as well. When that happens, when the degrees equal each other, then the horizontal asymptote has a lot to do with the leading coefficient. So when we take a look at our leading coefficient for the highest degree, it'll be 2. That'll be in the numerator, and the coefficient of x is 1. So we say y equal to 2 is a horizontal asymptote, and that's what we see right here. We're going to practice this on the next few problems. Okay, let's take a look at trying to graph this before we go to our calculator. The first thing we ought to do is find the zeros, and finding the zeros is making the numerator equal to 0, and that will happen when x is equal to 0. So when x is equal to 0, we're going to have 0, and we do know one of our points in our graph. Now let's take a look at the denominator, and this denominator, let's look to see when it's going to be equal to 0, and it'll be equal to 0 at -1. So that tells us a vertical asymptote. So this will be the vertical asymptote. There will not be a value at x equal to -1. That's why I put across this out. Now the degree of the numerator over here is 3. The degree of the denominator is 1, and that tells me there are no horizontal asymptotes. So I'm going to go to my calculator now, take a look at the graph, but I already kind of have a suspicion what it looks like. And here's this, and I'm just going to go to graph. And that's what we have. So we'll go ahead and copy that on our graph here. So it's looking something like this, and it follows this and goes like that. Okay, so let's go ahead and take a look at the domain. The domain is x such that x cannot equal -1. I like to use set builder notation when I don't want a value here. My range, it looks like all real numbers. So we can go y such that y is the element of all real numbers. That says we can have anything right here. Now in behavior, as x goes to -infinity, it looks like f of x wants to go to infinity. And as x goes to positive infinity, it looks like f of x wants to go to positive infinity. So now we have some information about this. Okay, let's take a look at this next example. In this next example, notice that I did some factoring. Now, the numerator will be equal to 0 when x is equal to -3. So at -3, y will be 0, and at x equal to -2, y will be 0, and I can go ahead and graph those 2 points. So I have some information about 2 points. Now I'm going to set the denominator equal to 0, and that'll allow me to find my vertical asymptote. And I'm going to write this vertical asymptote, and it's going to be right down here. Now the degree of the numerator is 2. The degree of the denominator, that means there's no horizontal asymptote. I'm going to let the calculator help me. I'll go to y equals, and I'm going to go over here, turn this guy off, and now I'm going to go down 1, enter, and this represents the graph I want, and I'm going to go ahead and graph. Okay, and so notice that it wants to follow the asymptote, and so I'm just going to go ahead and graph. It looks something like this, and it wants to follow this asymptote, and over here it's following the asymptote and then goes like that. Okay, so the domain is x such that x cannot equal -1. I like to use set builder notation. And over here the range is y such that y is all real numbers, and we can just write it that way. In behavior, as x approaches infinity or negative infinity, f of x, it looks like it's going to negative infinity. As x approaches positive infinity, it looks like f of x approaches positive infinity. Your turn. Pause to see what you can do. And here are the answers. Pause to see what you can do. And here's the answer. Okay, let's work at an example where the degree of the numerator and the degree of the denominator are the same. Okay, step 1 is what we were doing before. We want to find the zeros, and that's going to happen when the numerator is equal to 0. So let's go ahead and factor, and I'm going to put a 2 here and a 1 here to create this 4x. I'm going to put a minus here to create -4x, and then I'm going to put a plus here, and then that's going to now be equal to -3x. So that's going to happen. I'm going to put a little table here right next to it, x, y. So I know when x is equal to 2, when x is equal to 2, I'm going to get a 0. And when x is equal to -1/2, all I'm doing is setting this equal to 0. So at -1/2, I am going to get a 0. Okay, I want to look at vertical asymptotes, and that's going to happen when x squared minus 9 is equal to 0. And I know that's going to happen at x equal to 3 and x equal -3. So I'll go ahead and put those asymptotes in. That's a vertical asymptote, 1, 2, 3. Here's my other vertical asymptote. Okay, now I want to take a look at the degree of the numerator. And the degree of the numerator is 2. And the degree of the denominator is 2 as well. Now when they're both the same, then we look at the coefficients. So it'll be y equals, and the coefficient of the highest power is 2, and the coefficient of the highest power here is 1. So y equal to 2 is going to be a horizontal asymptote. These are both vertical asymptotes, and this is a horizontal one. So I'll go ahead and draw that. These are all going to be clues to how I graph it. -1/2, 0. That's going to be right here, and 2, 0. So I know the graph wants to follow those. All right, let's let the calculator help us. And so I'm going to go to y equals, go down here, turn this one off, and then I want to go to this particular one, turn it on, and then graph. And you can see how the graph wants to follow those asymptotes. Okay, so I'm going to go over here, and I know the graph wants to follow this asymptote and then follow this one. Follow this asymptote, go a little above, and then follows it down, follows this asymptote, and then follows it over here. Okay, so the domain will be x such that x cannot equal, and there's two values it cannot equal, and that's 3 and -3. Now the range, there's a problem because there's a value that a y value that I can't have. So y such that y cannot equal, and it doesn't want to equal 2. All right, and in behavior, as x goes to infinity, y goes to, or f of x goes to, it looks like it wants to negative infinity. X wants to follow the horizontal asymptote, which is 2. As x goes to positive infinity, f of x wants to follow, as it goes to positive infinity, it wants to follow 2. It wants to follow the horizontal asymptote. Okay, let's go ahead and do it again. Let's make a little chart here for our zeros. So to find a 0, you set the numerator equal to 0, and that's going to happen at 2. At 2, the fraction becomes 0. So I know we have a 2, 0 here. Now I'm going to set the denominator equal to 0 to find my asymptotes. So x minus 4 is equal to 0, so x is equal to 4. So I'm going to go ahead and draw my vertical asymptote. And this is a vertical asymptote. Now I'm going to look at the numerator degree, and that is 1. And the denominator degree, and that is 1. When they're the same, we now look at the leading coefficients of the numerator, which is 1, and the leading coefficient of the denominator, which is 1. So y equal to 1 is a horizontal asymptote. So we'll just go ahead and draw that. All right, and we're going to go to our calculator to help us graph the rest of it. So we're going to go to y equals, and then I'm going to go down 1 and go ahead and graph. And so what the graph wants to do is it wants to follow this asymptote and then go down and then follow this vertical asymptote and then follow the horizontal. So the domain is x such that x cannot equal, and the x value that we can equal is 4. And the y value we can equal is this horizontal asymptote, which is 1. In behavior, as x goes to negative infinity, f of x wants to get closer and closer to the horizontal asymptote, which is 1. As x goes to positive infinity, f of x wants to do the same. Follow that horizontal asymptote. Your turn. Here's the answer, and this is the end of part 1.